Hello everyone, let's solve this problem LeetCode239 sliding window maximum. So for this problem, let's see, you are given an array of integer names. There's a sliding window of size k which is moving from the very left of the array to the very right. You can only see the k numbers in the windows. Each time the sliding window moves right by one position. So we're going to return the maximum sliding windows. Okay, so here's the example. This is the names. It's 1, 3 minus 1 minus 3, 5, 3, 6, 7. And the size of the windows is 3. K equals to 3 in this example. So the output, okay, so the output is here. So the first window, the slide window, the size equals to 3 is 1, 3, 1. So the maximum is 3, right? And then the sliding windows moves right by one position, and then this by one position here. Okay, just 1 second. Okay, so we can see here, and then after we move one position here, the maximum one is going to be 3. So here, the maximum one is 3, and then we move one position right. And then in this slide window, the maximum one is 5. And then we move one more step, the maximum one is 5. And then we move the maximum one is 6, and then we move this window, the maximum one is 7. So this is basically the problem, and then we return this array. Okay, yeah, this is basically the problem. Okay, this is the problem. So let's solve this problem by using two different methods. So first, let's solve this problem using the brute force algorithm. So for the brute force algorithm, we start from the index 0. So it's 1, right? And then the first window is gonna be 1, 3 minus 1, right? This is the first window. And then we check if this element is greater than this one. Yes. Then the result for this window now is 3, and then check this one too, and then we can get the maximum one. So and then we move one position right, and we get another. Okay, we got this one, these windows, and then we get the maximum one is 3. Okay, and then yeah, this kind of the brute force algorithm. So for this algorithm, the number of windows gonna be n minus k plus 1, right? Because we have the size of the windows is k. So how many windows we do? We do have n minus k plus 1. Okay, so the time complexity for this one, so it's gonna be how many windows? We have n minus 1 minus k plus 1 number of windows, and then we're gonna check k times the size of k. So in this one is roughly around is big O and k. That's the time complexity for the brute force algorithm. And then let's try to have another algorithm to make this faster. So okay, let's copy paste this part. Okay, so another algorithm we are going to use is called a next greater element. So in this problem, we solve this problem. We use DQ. DQ is nothing but it's double linked list. Okay, so its double linked list is being implemented at the backside. Okay, so double linked list, actually we can push front, we can pop front, we can push back, we can pop back. Okay, this is kind of the double linked list. So for this problem, we are going to use a deck, array deck. Okay, also you can use a double linked list. Okay, so here's the example. Is 1, 3, minus 1, minus 3, 5. It's basically this example, okay? This is the one. And then first we're gonna do, we will store the element in the DQ only in the current window. So current window, the size is 3. So let's say the 1, 3, minus 1, and then we can store this 3 element, and then this is this 3 element, and then this 3 element. Yeah, something like that. Okay. Just 1 second. I don't know why today my mouse is not working. Okay, this is a problem. Let's do this. This is a step we are doing. So first, we're gonna check the front. Okay. Inside the deck, we check the front. We will pump out if it gets out the Windows size. Here is K. Okay, and then we check if this element smaller than the current, and then we maintain the element in descent order, and then we push the current node, and then we kind of include the maximum current Windows I greater than K minus 1. So how should we do for this problem? Let's say here is I. We iterating the array start from the first element. So what we do, we just do this way. Let's say this deck. Okay, let's start from the element. The first element, we check the first element when equals to 0. So if the size of the deck is if it's get out the window size is 3, but now it's 0. I mean, there's nothing here, so we don't have to do this way. We don't have to pop out anything, and then we will check this one. The index is 0. The element is 1. Is smaller than the current. Because here is none, I mean it's empty, so we don't have nothing, so we don't have to do the it's not satisfy this condition, and then we push current current element. Okay, push current element. So the current element for this case is 1. Okay, the index is 0. So the DQ actually store the index. Okay, for this problem, let's do this way. Actually, this index and the value is 1. Okay, and then we iterate the second element in this array. So here, when I equals to 1, the element is 3. We check the front of the deck. The size of the windows here just 1 is still smaller than 3. So and then we do the step 2. We check the numbers I. This element. Now this element is equals to 3. This 3 is greater than the current than the one in here. So what we do, we just pop this out. We pop this out, and then we push the current element is 3. We push a 3 here, so the index is 1. Here is a 3. Okay, this one we pop out. And then we push this one, and the current window when I greater than K minus 1, and then we include the maximum. But in this case, the sliding window, the size now is 2, right? We have 1, 2. We have 0, 1. So it's not satisfies this condition. Then we iterate I. to here. Okay, now I equals 2, the element is -1. So we will check the front. If this one if this Windows grade get out the Windows size, the Windows size is 3, now is equals to this one, so we don't have to care about this step. And then we will check the -1 smaller than the current one. The current one actually is 3. Yes, it's smaller than that one. So what we do, we just push the current element, because we are trying to keep the descending order, because -1 is smaller than 3, so it's in descending. So we will keep this one, and then we iterate the next one. No, the step 4. Step 4 is include a maximum of current windows when I greater or equals to k minus 1. Okay, so for this element, we can see the maximum one is 3. So our result here is 3. Okay, we are saving 3 in this results. Okay, and then we iterate one more element. The element the index is 3, the value is -3, and then we will check this one. Right now we have this size 1, 2, 3, but we have 1 here. But in this stack we have 1, 2, so it's still in the Windows size 3. So we okay, and then we will check -1. No, -3 is smaller than the -1. Yes, and then we push the current element is -3. To here. Okay, the index here is 3, right? And then we push this one, and then we include a maximum of current window. So the current window, the maximum is 3. So we do 3 here, and then we iterate one more. This I equals to 4. And then we will check the size of here is 3, right, in the deck, and it is equals to current window size, so we don't have to pop anything. And then we will check the 5 is greater than the current one. The current one is 5 is greater than this one. Yes, because we are trying to maintain the element order in a descending order. So in this way, we need to pop this out, and then we will check the 5 is greater than -1. Yes, and then we pop out -1. Okay, and then we check 5 is greater than 5. Yes, and then we pop 3 out. Okay, this is basically the procedure. And then the DQ now is empty. And then we push the current element. Current element actually is 4. Here is gonna be we push 5 in here. Okay, and then we will include the maximum current window. The maximum current window actually is 2, 3, 4. We only have 1 element right now, and then it's gonna be 5. So here we will do it's gonna be 5. Okay, it's gonna be 5. And then we iterate one more time. So we try to check. So right now our window is a 3, 4, 5. It's a 3, 4, 5, right? And then we check here. The element, the index here is 4, so it's still under the Windows size. And then we will check the 3. We will check the 3. Is greater than the 5. No, then we just push the 3 here, and then here is 5. Here is 5, and push this one, and then we will do q.pick. So we will check the greatest value inside the DQ is 5. So here we just put 5 here. Okay, and then and then we will do iterate one more time. I equals to 6, right? And then we have 4, 5, 6, and the index is 4, 5 is still smaller than the Windows size. So, and then we will check the index 6. The value of index 6 here is 6. 6 is greater than 3. Yes. So we are trying to maintain the descending order in this way. 6 greater than this one. So we pop this 3 out. And then we will check a 6 greater than 5. Yes, we pop the 5 out. Okay. And then we push the 6. We push 6 in the DQ. So this is what we do. We push this one here, and then we include the maximum of current window. So the current window is a 4, 5, 6. So inside the DQ, we only have 6 here. So here will be 6. Okay, and then we iterate one more element is a 7. Okay, so we will check the size here. Right now only have a index 6. Our actually the sliding window is 5, 6, 7. So the 6 still inside these windows. So and then we try to maintain the element in descent order. So in this way, the 7 is greater than the 7 is greater than 6. Yes. So we have to pop this out. And then we push the 7 in the DQ. Okay, after we push 7 in the DQ, we include the maximum of current windows. The maximum of the current window, the current window is a 5, 6, 7. The maximum one in this current window is a 7 now. So it's a 7. Okay, so and then we iterate one more, and then this one is greater than the names.length, so we just stop the loop. Okay, so here basically the result, we just return the result. So for the time complexity for this problem is ON, because we only iterated from start to the end, right? So that's why the time complexity is ON. Let's start coding for this problem. Okay, so what we do first, first we will kind of no, and so we will actually define the length of the names. The array is n, and then we new an array. The name is answer. We are going to put our answer inside this array. Okay, so the Windows the result, the Windows number is gonna be n minus k plus 1, right? So we just put this in our result, our answer, and this is r equals 0 at the beginning. This is our result, the maximum number. Okay, so first what we do, we're gonna store the index. Okay, first we store the index to the DQ. So what we do, we just do DQ integer q equals to new array DQ. Okay, and then what we do, we iterating our array. I equals to 0, I smaller than numbers the length, I plus plus. Okay, so and then what we do, the first pop out if it goes out of window size k. Okay, so what we do, we check if this q dot is empty. If it's not empty, and q pick, because actually the DQ we are storing the index of the current window. So here q.pick is gonna be the index, the first element of the index. No, the first index inside the DQ. So if this one, so let's say for example here, so the first one. So if our DQ only have 1, 2, 3, so when we pick, we're gonna pick the first element here. So if this one equals to I minus k, that means that our window size is k plus 1 is more than k. So we need, what we do, we just pop out q the pull, okay. And then what we do, we are trying to maintain elements in descending order. Okay, so what we do, we trying to use a while loop. If q dot is not empty, and numbers q dot pick last, if this one smaller than numbers I, if it's smaller than that one, so what we do, we pop it out, because we are trying to maintain the element in descending order, so the first one have to be the largest. But if it's smaller than that, then we just pull, okay, and then we check again. If it's not empty, we will check this, the pick the last one. If it's smaller than the numbers I, we will just pop, and then we will push the current element. Okay, q dot, we will offer it. We'll offer I inside there. Then the last step of what we do, we just include the maximum of current window. Okay, the I greater equals to k minus 1. Okay, so how do we do? We just check if I greater equals to k minus 1. Then what we do here, we just do answer r plus plus equals to numbers. Okay. And then eventually what we do, we just return the answer. Okay, let's check the code. Okay, accept. Let's submit the code. It's wrong answer. Okay. Okay, let me check what's the problem here. Just 1 second. Let me check this one. Okay, let me check what's the problem here. Okay, the problem is here. So when we check if Q is not empty, and the last one in the queue is smaller than the numbers I, so we will pop the last one. We will pull the last one, the Q dot last. Okay. Okay, let's run the code. Okay, let's submit the code. Okay, our code is faster than 65% of Java online submission for this problem. Okay, thank you for watching. I'll see you next time.